to Whiteboard Science. I'm Pranav, your host. Today our lesson is going to be about analyzation and graphs. So if you've watched the scientific method video, the link to that video is up here. We talked about the scientific method and the steps. So there's 6 steps, and analyzation is step 5 of the scientific method. And it's basically where we analyze and organize our data that we collected from step 4, which is procedure. And we did a video on that. So analyzation, so what you use to organize, so this step is basically organizing and analyzing the data. And there's this chart that you use, it's called a graph, and it's used to organize data. So our big question is, what is a graph? And we basically answered it. A graph is a chart used to organize data. So let's write that down. A graph is a chart used to organize data. And so data is one of our vocab words. So data is basically like what observations, the observations that you collected from your procedure. And if you want to watch a procedure video to learn more about observations, the link to that video is up here. So a graph is a chart to organize data. Now let's talk about the parts of a graph. So a graph has to have parts to be a graph in the first place. So in our picture space, I'm gonna draw a basic layout of a graph, and then I'll talk about all the parts. Okay, so this is what a graph should look like before we even marked anything. So you'll see I've labeled Y here and X here and 0 over here. And I'll tell you why. This, I labeled X here because do you see this this horizontal line going right here? That is called the x-axis. So each line over here is called an axis. So this vertical line is an axis, and this horizontal line is an axis. And each axis has a name. The name for the horizontal axis is X, and the name for the vertical axis is Y. So the vertical is Y and horizontal is X. So that's one thing to remember. So horizontal is, I'm just going to put horizontal equals X, vertical equals Y. That's what you should always remember. The horizontal line is the x-axis, and the vertical line is the y-axis. So I've written that over here. And if you see a star, that means it's something you should remember. So you should definitely remember this when you're making a graph, so you don't get mixed up. And I'll tell you why later in the video. So now for the next part, we have to take a sample. We have to take a sample question and a sample procedure. So let our sample question be, how many animals are taken to the zoo each month? So on average. So we can find this out by so I'm going to use a bar graph, and I'll explain the different types of graphs later. But so I'm just going to do the first 5 months on average. So J, January, F, February, M, March, A, April, M, A is May. So each tick mark represents a different month, and on each tick mark you'll mark so each, I should have put one of our vocab as label, but a label is basically the name of these all these tick marks. So in this case, our label for this side, because it's January, February, March, April, May, they're all months. So our label for this would be month. months. Sorry, I spelled that wrong. Oh, actually, I spelled that right. Okay, months. So that would be our label for this one. And we want to know how many animals get shipped to the zoo each month. So on average. So what we should have done in our procedure, I might have not explained this, but the observations you make, you have to gather in something called a data table. So I'll just do a small data table off to the side here. So a data table basically looks like this, and so let's do 4 lines because then it'll divide it into 5 parts, and let's label each part with the month. January, February, March, April, May. So what we've done here is made a data table. This is the kind of data table we should have made in our procedure while collecting our observations. So let's just say these are random numbers. Let's just say in January, five animals were shipped. In February, 10 animals were shipped. In March, there were 10 animals shipped. April, 25 animals shipped. And May, 30 animals shipped. Let's just say that. They're just random numbers. So what we do now, we have our data table that we collected from our procedure. Now we have to convert this into a graph. So this side is the number of animals. Just extending this so you can see. So this is the month, but this side should also have a name. The number of animals, because we're putting the number of animals that is corresponding to the month because of the observations we made. So this side, the horizontal line, gets converted to the other horizontal line. So a data table is very, very easy to convert into a graph. Well, at least in my opinion. And I'll show you how. The horizontal line, either the top or the bottom, it's the horizontal line. And it's labeled with the months. And then we just move the months to the horizontal line. So it's that easy. And the vertical line is the number of animals. So our label for the vertical line would be number of animals. So that's the label for our vertical line. Because see, we just moved it here so this is technically, imagine it like this. This is the x-axis and this is the y-axis. And then just convert it to a graph. It's that simple. And now what we do is from our data table, we take the highest number. So the lowest number is obviously 0. And the highest number in this case is 30. So let's mark the very top of the graph with 30. And the reason I'm doing the reason I'm doing 30 over here is because it's the number of animals. What's the label for this? Number of animals. So the label for this one is the months. Remember, we moved it from here to here, and this is the number of animals. So we just moved that from here to here. So the number of animals, the highest number of animals is 30. So we just move the 30 from here to here. Because we do 30 on the y-axis because number of animals is on the y-axis, and these are the numbers of animals. These are the numbers of animals. So now let's go from 0 and let's go up by 5. So when you go up, see, you know how you have to mark like 1, 2, 3, 4, 5, 6 all the way up to 30? You don't have to do that. You don't have to go up by 1s. You can go up by 2s if you want, 3s, 4s, 5s, 6s, 7s, 8s, 9s, and 10s. I'm going to do 5 because we have 5, 10, 10, 25, and 30. And they're all divisible by 5, so it's going to be easy to graph. And I'll show you why. So let's do 5, 10, 15, 20, 25, and we already have 30. So it goes 5, 10, 15, 20, 25, 30. Now, what I'm going to show you now is something called a bar graph. I'm going to get a thicker marker so you can see how I'm going to do this. Okay, I'm back. So, I'm going to show you how to do a bar graph. Let's just make that that. And yeah, so now what we have to do is, well, we have all of our numbers, which is the number of animals. We have all our months. Now what do? We don't know, like, it's just numbers and letters. So we don't know what the point of the graph is. Like, so now what we have to do is, this is a graph called a bar graph. So I'm just gonna put it here. Bar graph. So it has a bunch of bars, like bar, bar, bar. You might have seen these graphs before, like if you're looking at statistics and stuff. But yeah, so you might have seen these kinds of graphs before in your lifetime. So they're just a bunch of bars, and they kind of like mark, like, so January. I'll show you. So you see January and January. So what we see here is the x-axis is and the y-axis. So technically, what we do is we move the y-axis all the way to January, which is the first column. What number do we see in this box? 5. So we mark a line at 5, and then we just make a bar like this. See? And then we shade it in. So that's why they're called bar graphs, because we do bars, and the bars go up from 0, which is right here, all the way up to the number that we see on our data table. So now, this is February. We need to find out February. So let's move our y-axis all the way to February. The number we see inside that box is 10. So we mark a line. So we match up February and 10, and then mark the line at February and at 10, and just draw the bar down. That simple. Now let's do it for all of our. Now I'm gonna do one more as an example, and then let's see if you can do it by yourself. So 10. So if we move the y-axis all the way to March, because March is our next month. So if we move it, the number we see in this box is 10. So we match up March and 10. We draw a line, and then we create a bar. And just shade it in. Okay, now I'm gonna do the rest and then come back. Okay, so now we have completed our graph, as you can see here, and I forgot to actually tell you about 2 things. 1, the title, and 2, the legend. So or the key. So the title is the title of the graph, so the name of the entire graph, and that has to relate to what our graph is about. So our graph is about number of animals shipped to the zoo. And that's our title. So that's basically the title is the name of the graph, and that's our vocab word. And the legend, which is another one of our vocab words, is basically the key of the graph. So people can like know what they're talking about, what all these lines and stuff mean and colors mean. So say in some graphs, they can put different colors that mean different things, and they might not have labeled it like this, so that's why they have to have a legend so people can know what they're talking about. In this case, our legend is animals shipped in is the color red, and you can see they mark the points. So now you can actually do another type of bar graph. So say our question was, how many animals are shipped in and out of the zoo per month? So it would be in, also out, like what if they're being freed or something. So I'm gonna grab a new color of marker. I'm back with green this time. So now let's just say this is the numbers, but for shipped in, but say the numbers for shipped out. So now our data table would change. So let's just erase all this. Now, this would be our this would be our y-axis, but we would divide this into 2 lines now. 5, 10, 10, 25, 30. So the reason I divided into 2 lines is because one is shipped in, so I'm just going to put in, and this one would be shipped out, because that's our question. How many animals are shipped in and out? So let's just say I'll do 10, 5, 3, 35, and 20. Yeah, that's good. So shipped in is 5, 10, 10, 25, and 30. Shipped out is 10, 5, 3, 35, and 20. Let's just say that. So now what we do in our graph is, how do we show how many were shipped out? You can create another graph, but there's also a way you can just do it in one graph. So actually I'm gonna get my red marker. Yeah. So I'm gonna actually erase all of this. Okay, I am done erasing. Well, that's a lot of erasing. Okay, now I'm done with erasing. Holy cow! Look at all that. See? Okay, that's a lot of erasing. Should have used my big eraser. But anyways, let's do now in our legend, since we're talking about something, we're talking about out too. So let's just erase this. Let's put in and out. Now we'll do animal shipped out in green. So now I'll show you how you can do all this in one graph. So I'm just going to place my pointer stick here. So first let's do in, because that's the first one. So January 5, mark this here, but don't make the bar yet. Just mark where it should be. So January and 5, they meet up at that point, mark the line, and animal shipped out 10. So January, and then 10. So do it off a bit to the side because we need room, and I'll show you. So move the bar like this. So that's one bar. And then our next bar will be like this. So these are our 2 bars, and now let's shade them in. Red and green. Okay, I've shaded them in. Now this is what a graph with two comparisons, like a comparison coming out would be like. So a comparison between in and out. So but we want to do them together in 1 month. So we would put both of the bars over January. Now we can't do it the same color because then people will think it's the same thing. So if we do it the same color, like say if we did both of them red or both of them green, then they wouldn't understand. They would think it's something different. So that's why we have to do it in 2 different colors always. Or label them something different, even though they're the same color, like label them. If we're doing 2 in one 2 y-axis and 1 x-axis. What I mean by that is 2 like bars coming up on the x-axis. So now I'll do another example one. So this is 10. The number of animals shipped in is 10 and shipped out is 5. So shipped in is 10. So for February, we match up February and 10, and we mark the point. Now, we only have to do it halfway because we need space for the other bar too. So the other bar is 5. So February and 5, leave some space. And yeah, now you can make the bars. So just come down. And come down. and you can mark them again. Just gonna do that. And that. So as you can see, the red is in, and our in, if we match in and February, it's 10. If we match out and February, it's 5. So we mark that on the graph. Now I hope you understood this. I'm gonna go through one example, and then I'm just gonna finish the graph. So one more example. 10, which is, so we match in with March 10. We match out with March 3. So let's mark 10 first. So we mark 10, leave the space. Actually, I'm just gonna do the bar already, so it's easier. So, and then match 3, or about where 3 would be, and then just mark the line and make the bar and shade it in. So shade in the green and shade in the red. Okay, so now I'm gonna go ahead and complete the rest of the graph. Okay, so I finished the bar graph here, and this time it has 2 animals in and animals out. Yeah. So now what we basically did was converted all the data that we gathered from the data table, and we just plopped it in the graph. So, and we basically, the x-axis is horizontal, the y-axis is vertical, and we just marked both of them, both of them because out animals and in animals. So we marked both of them on the graph because our question was how many animals are transported in and out of the zoo. So now let's recap the parts of a graph. Title, legend, x-axis, y-axis, labels, data table, and this is the data, the red and green. That's basically all the data because this is the data we collected and we just put that data here. So this is still the data. So yeah, now let's talk about the types of graphs. So there's 3 different types of graphs. Well, there's more types of graphs, but we'll talk about the most popular 3 today. The 3 types of graphs that exist are bar graphs. We obviously talked about it over here. There is pie graphs, and no, not the pie that you eat, but it's in the shape of the pie that you eat, and which hence their name. And there are line graphs. So bar, pie, line, BPL. Bar graphs, pie graphs, line graphs. Bar graphs, pie graphs, line graphs. Bar, pie, line. Sorry. Let's talk about a pie graph. Since we already talked about a bar graph, it's time for the pie. Okay. So a pie graph is basically a circle. And that's the first part. So instead of having 2 lines like a bar graph and a line graph, a pie graph is a circle. Oh my gosh, I suck. Okay, so a pie graph is a circle. And that's why it got its name, the pie graph. So a pie graph basically is like, so how do you say it? Let's take the same title for the pie graph. Number of animals shipped to the zoo. Now, you can't, like a bar graph and a line graph, you can't put in 2 values. Like there's animals shipped into the zoo and out of the zoo. So let's just take into the zoo. And I think our numbers were 5 in January. So I'm just gonna do I'm gonna do J5, F10, M10, A25, and MA30. So yeah, and how you fill in a pie graph, well, a pie graph has to do with percents. And I'll explain this more in my math videos, which I'll be making later. So percents. This all has to do with percents. And because we have to find out what percent of the circle they take, and that turns it into a graph. You might have seen pie graphs, also in statistics and stuff. And if they're like comparing two things, like comparing two or more things, like they put in like divisions, and then they like say the elements in our atmosphere. There's like nitrogen is like 76%, oxygen is like 21%, carbon is 1%, 0.9%, and 0.1% is other gases. You might have seen a pie graph mentioning the different atmospheric gases. So like that, that's an example of a pie graph. So so here's an example of a pie graph. And yeah, so that's what a pie graph is. And that's basically what it looks like. So an example of it. Now let's turn this circle into a pie graph based on the data we have. January 5, February 10, March 10, April 25, and May 30. So how we can turn this? So first we have to find out, so add all the numbers together. And I'll explain how to find percents and stuff. So I'm just gonna fast forward through all the math stuff, and yeah. Okay, so we are done with our pie graph, as you can see over here. I recorded all the percents for them each month. January is 6%, so it takes up 6% of the entire circle. So you see, this is equivalent to 6% of the entire circle. So 6/100ths, which is 0.06 as a decimal, and which is 6%. And February is 13%, so 10/80ths is about 13%. So 1/8 is about 13%. It's actually 12.5, but I just rounded everything. So they still add up to 100, fortunately. So January is 6%, so 5/80ths is 6%. Because why I'm saying 80ths is because 5 plus 10 plus 10 plus 25 plus 30 is 80. So you have to add all of them up, and I'll explain about all this stuff in one of my math videos. So 6, 13, 13, 31, and 37. And both of these are the same because, as you see, 10 and 10 are the same. So yeah, that was the pie graph. A pie graph is basically a graph where you divide into sections based on how much percent of the circle it takes up. So yeah, that was basically a pie graph. So this is the end of graphs part 1. I hope you liked the video and understood everything that I said, and we'll see you in our next video. This is Whiteboard Science. Please subscribe to my channel, hit the bell icon and the like button. Thanks for watching. See you in our next video.